Hey guys, I made this numerical FDTD tutorial video so that it can be helpful when you do the project at home. So, as we discussed in the class, first we create a new project of FDTD and we save it. Click File, click Save, and for example, we create a name as 2D Waveguide Test. Okay, so the first step is to create our waveguide. Click this button here and click rectangle. Then you have this waveguide. And the next step is to right click the rectangle and add it. So first we want to change the geometry. As we discussed, we assume the length in the x direction to be 4 micron and the height in the y-axis to be 1 micron. So for the z-axis, it's very trivial because it's a two-dimensional simulation as we discussed in the class. So a random value, for example, 1 should be okay. And click apply, okay. And then we add our FDTD simulation or the region of interest. So in the button here of the simulation, we click it and we click the region. Then follow the same procedure, we need to define its geometry. So right click it and add it. First, change the dimension to 2D. And then in the geometry, we change the value to be the same as the waveguide. For example, 4 and here 1. And the very important part is the boundary condition. So because the wave propagates in the x direction, so for the x boundary we do not have to change. It's a perfect matching layer. And for the y-axis, for 2D waveguide, these two should be PC or metal here. Therefore, we set the y-min boundary to be metal and y-max to be metal. And we click apply. And OK. So to have a better view, we can always press this zoom extend. Okay. And one more thing is we need to give the refractive index of this rectangle. So this is how we do it. Right click it, add it. We click the material. And for this index, we can give it to any value. For example, 1, so this is air, and 100 and 1000, or even -1. So here we use air to demonstrate because it is the simplest. And we click apply and OK. Okay, so far so good. Then we want to add the mesh. We click the button here and click the mesh. In case if you don't see this, you can write your script here in the script prompt. We just input add mesh. You can also see the mesh here. Okay, so I'm going to delete it. So for the mesh, follow the same procedure. We right click it and add object. So for the mesh size, as we discussed in the class, it must be smaller than lambda over 10. So now we are going to simulate a waveguide with 1 micron. So it must be smaller than 0.1, right? So for this simulation, as we show in lecture, we set it to be 0.01, and the z-axis actually doesn't matter, but just give it a value the same as the dx and dy. And then we click apply and we choose the map geometry here. So as we also discussed in the class, we want the mesh to be larger than the simulation region. So the x should be larger than 4, we give it to be 6. For example, the y should be larger than 1, so give it to be 2, and apply. So you can see the mesh region is larger, right? Very obvious, and then we can click OK. So for the Z span, doesn't matter. 1, 2, both OK. And also we click the zoom extend to have a better view. So here, if you press this button here, view simulation mesh, and you can zoom this area. Can you see this orange line? So this shows you what the mesh looks like. Okay, so this is dx and this is dy. So dx equals to 0.01 and dy also equals to 0.01. So you can actually see the mesh. And then to zoom extend, you see the whole view, and then we cancel this mesh view. Okay, so then the 3-step is not that difficult. The most difficult part comes right now. It is we add the source. So first we click the FDTD and click the port here. And since we are going to use 2 port, we double click it. Then we have 2 port. So first we click the ports here. This ports, you can say it will it shows you the wavelength of the wave. Okay, so if you right click it and add object and click the set global source setting, and here you can actually change your simulation wavelength. So for our case, it is 1. So for the start, we set to be 1, and the stop we also set to be 1. So if you want to set a frequency, you can change the frequency. It will do a calculation. Okay, and you click apply and OK, and OK. So, and in this step, we give you the simulation wavelengths. So later for your project, if you want to change the wavelengths, you just change here. Okay, for example, 2, then it will be 2. Right, quite straightforward. And then comes the important part, is the mode. So as we learned from the lecture, there are different kinds of mode inside the waveguide: TM, T1, TM1. So here we right click the port 1 and edit. So first I'm going to define the geometry of the port. So here, if we say that the wave will be excited in this part and propagate to the right hand side, and as we discussed in the class, we don't want the port to be very close to the simulation, to the left boundary of the simulation region, because this is a perfect match layer. It will affect the whole simulation. So this should not be -2. If it is -2, it will just merge with this boundary. So for better simulation, we put it to -1.5. Okay, and for the Y span, it is better if we set it to be larger than the simulation region. For example, 1.2, 1.3, 1.4, both okay. And we click apply. Then in the modal property here, we first change the fundamental modes here to be user select. Okay, and then we click the select modes button. Let's expand it a little bit. And in this area, we scroll down and we click calculate modes. Now you can see the modes that calculate. So, and then in this lecture, in this tutorial video, we are going to simulate 3 modes. 1, 2, 3. How you select this? You press the control button on your computer or your PC and click one by one. Okay. So 1, 2, 3, and you click the select modes. And you can see here the modes are selected. And we click apply and OK. The same procedure for the port 2. Also, don't set it to be 2, but 1.5 because we don't want it to merge with the PML. Okay. So for the wide span, we set it to be 1.2 to be larger than the simulation region and apply. You can see that. And then for the model properties, here we change it to user select, just like the port. And select modes, scroll down, calculate modes. Okay, choose 1, 2, 3. Make sure the mode select here is identical to the port 1. Okay, otherwise it will cause some computation error. Okay, select modes and apply and okay. Then we successfully have our excitation source. So the next step is to introduce a monitor because the results will be stored, will be recorded by this monitor. Then click the model and click this button here. Click the frequency domain field profile. So as we discussed in the class, if we add the monitor in our final step, the coverage of the monitor will be automatically larger than the simulation region. Okay. But you can also follow the same step, right click it and add object. You can change the geometry here, for example, to be 10 and the y to be 4. Apply it. You can see it is larger now. Okay, as long as the monitor larger than this region is okay. And then all the things are set. Now let's simulate the first mode. How to select the mode we're going to simulate? You right click the ports and edit. If you want to simulate mode 1 and then click mode 1. If you want to see mode 2 and click mode 2. So let's see the mode 1 first. Oh, okay. Another thing we do before run our simulation is to check the simulation and memory requirements. Remember that. So you click the button here and you check the simulation. And this should be good because it's only 100 megabytes. Okay. So if it increased to 1 gigahertz, 1 gigabytes, it may take a long time. So why would this be increased? Maybe because of the mesh and the simulation region. If the region is too large, it will definitely increase, right? So make sure you check this every time you run the simulation. Okay. So now I've checked this and let's run it. Okay, very successful. All the simulation results are installed in the monitor. So if we click the monitor, we right click it and visualize. And this E is electric field, magnetic field, power. So let's see the electric field first. So for mode 1, this should be the picture you have. So because it's a plane wave, so the magnitude should be identical in the whole space. And let's see the x component is 0, right? And because the value is very small. value is very small. For the Z is 0. For the Y, you can see it's a typical plane wave. And then let's see the H field. Also, the magnitude is identical. For the X, 0. For the Y, 0. For the Z, is plane wave. Okay, so this tells you it is a plane wave or TEM mode. Okay, and then let's check the mode 2. We right click the ports and edit object and change it to be mode 2 and OK. So remember, if you want to visualize different kind of modes, you never change the port 1 or port 2. Only need to change the ports here. Okay, don't change the port 1 and port 2. So if you change it to mode 2 and run it. Also, and you can check you can see the result here. Right click it and visualize. Let's see the E first. Okay, you can now see the magnitude is no longer uniform but have some fluctuation. Let's see the X component is in this shape, Y component in this shape, and the Z component equals to 0. And this, now you can say this wave should be a TM wave. And let's double check. Visualize the H field. So for the H field, X component, Y component equals to 0, but the Z component had value, so it doesn't equals to 0. So this could shows you it is a TM wave, right? So this should be a wave profile for a TM wave, and this should be a TM1 mode, right? If you check your lecture note, and then let's change it to mode 3, apply it. Okay, run. The same step, visualize electric field. The X component and the Y component of the electric field is now 0. Only the Z component exists. And let's see the H field. The X component doesn't non-zero, 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 HZ equals to 0. Okay, so this definitely tells you the third mode, the mode 3, is a TE mode. So this is a TE1 mode. Okay, so I think this is it for your FTD learning. So later, if you do a project, if you want to change the wavelength, you can add it here, set the global setting, and change the wavelength, for example 1.5. Okay, and if you want to change the material inside the waveguide, you right click the rectangle and edit. You change it in the material, for example 2, 3, 100. So you just change here. The most difficult part is that if you want to change the height of the waveguide, and in this case you need to change many things. For example, if this change to be 1.5 micron, so the first step is you need to change the widespan for the rectangle 1.5, and you also need to change the geometry of the FDTD region, so this have to be 1.5. Okay, and for the port you also need to change the geometry, right? So this one should be larger than 1.5, so you may need to set to be 2, 1.8 something. And the mesh, just to make sure the coverage of the mesh is larger than 1.5. Okay, and the same for the monitor. So this is it. I hope you can enjoy the learning of the FDTD. Thank you.